Hi, my name is Michelle Fox with SAA Laser Institute, and for the next few weeks, I'd like to dive into physics a little bit. And I want to make it as simple as possible, and we're going to talk about the 5 laser parameters. So 5 laser parameters being wavelength, power, spot size, pulse duration, and hertz. We're going to do these one at a time. So the first thing we're going to go over is wavelengths. So wavelength is simply a measurement of light. And wavelength dictates 2 things in the laser world. It dictates chromophore absorption and it dictates depth of penetration into the tissue. So chromophore absorption, these are your 4 chromophores. This is what the light absorbs into: melanin, oxyhemoglobin, ink, and water. Then it also dictates depth of penetration, how deep we're delivering energy into the tissue. So let's look at this. This is our laser V. I really like the V because I think it is much easier to understand than certain graphs may be. And we're trying to make this as simple as possible. So we're going to talk about the laser V. And on the left side of the laser V, you have wavelengths that absorb into melanin, oxyhemoglobin, and ink. So wavelengths from 400 to somewhere around 1400 nanometers. But beyond those wavelengths, on the right side of the V, you have wavelengths that absorb into water. What we're going to do in this video is talk about wavelengths on the left side of the V only, and then in the future videos we'll talk about the right side of the V, because the rules can be a little different from one side of the V to the other, and we want to make this simple. So on the left side of the V, you have wavelengths that absorb into, again, melanin, oxyhemoglobin, and ink, starting at 400 nanometers and up to 700 nanometers. This is visible light. These wavelengths absorb really strongly into melanin. That makes them less safe for your darker skin types. These wavelengths also penetrate the most superficial in the tissue. And that's when we have issues with post-inflammatory hyperpigmentation, burns, and blisters, because when we're more superficial in the tissue affecting the melanin, which lies in the epidermis, that can cause more problems with our darker skin types. As we go longer in wavelength, and these are some of your more common wavelengths, your 755 alexandrite, your 810 diodes, and then your 1064 YAG, which is an incredibly common wavelength to see in our industry. These wavelengths are within near infrared and mid infrared light, making them much safer. As we get longer in wavelength, we have far less melanin absorption, and we are delivering energy deeper into the tissue. So on the left side of the V, you've got 400 to 1064, and then beyond to around 1400 nanometers, where melanin absorption pretty much drops off. Shorter wavelengths will penetrate more superficially and have the most melanin absorption, making them the least safe, and longer wavelengths will penetrate much deeper and have the least melanin absorption. 1064 namely having the least melanin absorption of all wavelengths that absorb into melanin on the left side of the V, making it the very safest for our darker skin types. So next video, we're going to talk about the right side of the V, and if you have any questions I didn't answer, you let me know.